Polar coordinates and polar equations. When we know about polar coordinates and polar equations, we can find out how to graph equations like this, r equals sine 2 theta, and like this, r equals 2 cosine 3 theta. This is the answer to exercise 7, example 7 on your handout. And this r equals sine 2 theta. This graph is the answer to example 6. So we'll get to how to graph these with a calculator and without a calculator after we go through introduction to polar coordinates. And we'll start with example 1. On your handout, we have the point -3, 2. These are coordinates. They're the x and y coordinates of a point. When the coordinates of a point are x and y, we call these rectangular coordinates. And of course, we know where the point is located with the y-axis and the x-axis. -3, 2 is this red point here. So what we're going to do is convert the coordinates to polar coordinates. So we need two things to do that, to get polar coordinates. We need the Pythagorean theorem, which is x squared plus y squared equals r squared. And we need the definition of tangent. The tangent of an angle, any angle, is y over x. So in this example, x squared is 9 and y squared is 4. So since 13 equals r squared, the square root of 13 equals r. In this example, the tangent of theta is y over x, so that's 2 over -3. I have my calculator in degree mode, and I am pressing the buttons, first checking to make sure it's in degree mode. Then I press second tangent 2/3, not using the negative, on purpose. Second tangent 2 divided by 3. When I do that with the calculator in degree mode, I see that theta, the angle I'm looking for, comes out to be about 33 degrees, closer to 37 degrees. But that number, 37 degrees, isn't theta. We call it theta's reference angle. So looking at the picture, we draw a vector from the origin to that red dot. The theta that we're really trying to find in this example is the angle from the positive x-axis to this vector that passes through -3, 2. And the angle we're looking for has a 37-degree reference angle, approximately 37. I got this by pressing second tangent 2 divided by 3. Well, now I can tell from the picture that the blue angle is 180 minus the reference angle. 180 minus the reference angle. So theta isn't 37. Theta is actually 146.310 degrees. So what are polar coordinates? X and Y are called rectangular coordinates. Polar coordinates are always given in the order r comma theta, where in this exercise r is the square root of 13 and theta is approximately 146.310 degrees. So there is the answer to example 1. What it means is if we have to dot this point, we would first rotate 146.310 degrees. In other words, we'd rotate into the second quadrant. Make a terminal side vector, whatever you want to call this. So the point we're looking for has this theta as one of its polar coordinates. So on this line here, we measure out the square root of 13 from the origin. Measure out a distance of the square root of 13. And where we end up, as long as this distance is radical 13, that's the point whose rectangular coordinates are -3, +2. So notice these are both positive numbers, because r means the distance from the point to the origin, and theta is the angle which is in the second quadrant. Example 2. The point is 4, 3. Those are rectangular. It says that in the question. And we want this point, they call it P, in polar form. The point 4, 3 is in the first quadrant. Find the polar form just means find the r and the theta. R is easy to find. X squared plus y squared equals r squared. 16 plus 9 equals r squared. So r equals 5. Theta is easy to find. The tangent of theta is y over x. Tangent of theta, in this case, theta means the angle between this and the positive x-axis. The tangent of this angle is 3 over 4, y over x. Press second tangent, 3 divided by 4, and the angle we get is about 37 degrees. And that, in this case, that's not only the reference angle, as in example 1, that's actually what this angle is, because it's in the first quadrant. Theta is 36.870 degrees approximately. So the polar coordinates of this point is supposed to be an r right there. The polar coordinates are always r comma theta, r comma theta. In that order, r theta, just like these are always in this order, x, y. Rectangular, x, y, polar, r theta. Example 3. We have the equation y equals x squared, which everyone knows what that graph looks like. But the question is to find the polar form of this equation. So here are the keys to this polar coordinates topic. The definition of the cosine of an angle is x over r. That's the definition. And the definition of sine theta is y over r. These are the definitions. You can think of adjacent over hypotenuse if you want to, and opposite over hypotenuse, but you'll need to use these. From this definition, you get x times 1 equals r times cosine theta. And from this definition, we get y times 1 equals r times sine theta. Any equation that has a y in it, like this, the y can be replaced with r sine theta. In any equation that has x, anywhere there is x, the x can be replaced with r cosine theta. So, y equals x, all right, see that exponent? There's x squared. We do want to be able to solve this for r, though. So here we call this y equals a function of x. We want the polar form to be r equals a function of theta. So rewrite this as r sine theta equals r squared cosine squared theta. And then you get one side to be 0. This is a common strategy. Get one side to be 0. 0 equals r squared cosine squared theta minus r sine theta. 0 equals, this side, both terms have r, so we're going to factor r out. The r that's in both terms is factored out here. There's no r there anymore. If something times something equals 0, and one of these has to equal 0. Either this has to equal 0, or this has to equal 0. Otherwise, how could this times this equal 0? So r equals 0, we're going to reject that. You should ask me why later. And this we're going to solve for r. R cosine squared theta equals sine theta. So r equals sine theta over cosine squared theta, which is the answer. So I'd like you to show me why the answer key, your handout has the answers. Why does the answer key say r equals secant theta times tan theta? Because I'm telling you this is the answer. That's r equals a function of theta. Answer key says this. So am I right when I say this is the answer? Is the answer key correct when it says this is the answer? So that's to think about. So the r equals a function of theta is the polar form of this, where y equals a function of x. The graph of this would be the same. Parabola that's up here. So example 4. X minus 1 squared plus y squared equals 1. We're going to get the polar form by replacing x with r cosine theta. Copy, 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 copy. Replace y with r sine theta. And copy the exponent and e equals 1. Alright, so there the x's and y's are gone. We only have r's and thetas. The definition of x is always equal to r cosine theta. The definition of y is always equal to r sine theta. We want to be able to get this to the form r equals a function of theta. We want r all by itself. So we multiply r cosine theta minus 1 by itself. We're going to have to FOIL. After the plus, we just have to square r sine theta. That would be r squared sine squared theta. So r cosine theta times r cosine theta is r squared cosine squared theta. R cosine theta times -1. And the inners are the same things. Combine those like terms, we get -2r cosine theta. And -1 times -1 is +1. Putting down all the rest of this. Let's rearrange the order. We're going to write this term and then this term. R squared cosine squared theta plus r squared sine squared theta. This term we're going to just copy, -2r cosine theta. And the ones cancel. There's a 1 here and a 1 here. We subtract 1 from both sides. In the terms that are green, r squared is in both. R squared is in both green terms, so r squared comes out of cos squared theta plus sine squared theta. And everything after that gets copied. So why is this r squared minus 2r cosine theta equals 0? So you're taking notes. If you don't know how this step turns into that step, make sure you bring that question to class. These two terms both have r. R outside of r minus 2 cosine theta. This r that's in both is factored out. The only way something times something can equal 0 is if one of these is 0. Either r equals 0 or r minus 2 cosine theta equals 0. R equals 0 doesn't make sense in this problem anyway. From here we get r equals +2 cosine theta, and we're done. That's r equals the function of theta. That's the polar form of this equation up here. This equation has x's and y's. The answer is r equals a function of theta, polar. Example 5. R equals 1 minus cosine theta. Because we now want the rectangular form, I'm going to replace cosine theta with x over r, which is good because at least there's an x. We don't want r's though. You have r's and thetas in the original. We want to end up with just x and y. Now this equation has a fraction, so we're going to multiply both sides by r. Multiply both sides by r. R times r is r squared. R times 1 is r. R times x over r is just x. And since x squared plus y squared is equal to r squared, this r squared can be replaced with x squared plus y squared. And since I can take the square root of both sides of this red equation, the square root of the left side, that's to equal the square root of the right side. So the r that's right here, make it blue, is the same as the square root of x squared plus y squared. The rest gets brought down like that. And we're going to say this is good enough right here. This equation with only x's and y's, no r's or thetas, is the rectangular form of the original equation, which was in polar form. You're going to skip to number 8 next, to graph r equals 4 cosine theta. We're going to talk about one way to graph it in class. Here we're going to graph this by replacing cosine theta with x over r. Cosine theta is x over r, definition. So r equals 4x over r. Multiply both sides by r. Then the r squared gets replaced with what it equals. R squared is the same as x squared plus y squared. X squared plus y squared is always the same as r squared. This and this are the same. The rest from here over gets copied like that. And in pre-calculus, in September, we did the following. This equation, which has x's and y's, we're going to write all the terms that have x, then all the terms that have y. There's no y to the first power here, so I'll write 0 y to the first. And then equals, if there's any constant, if there were any constant, it would go over here. Just rearranging these so the x's are first, then the y's, equals a constant. Complete the square. Half of negative 4 squared is positive 4. Don't forget we have to add that same thing to the other side. Half of 0 squared is 0. Don't forget to add that to the other side. This trinomial is x minus 2 squared. This trinomial is y plus 0 squared. And all of these add up to 4. This is the equation of a circle with center hk. When I say h, I mean positive 2. When I say k, I mean 0. And radius is the square root of this number. The square root of this number. Two 0 is the center. Radius is 2. Down over 2. Over 2. 2. Center is down 2. That's the graph of the polar equation r equals 4 cosine theta.